Exercise 4.2 is going to ask us to write a program with a main loop which is going to keep asking integers from the user, positive or negative or null. As soon as the user enters a null integer, we are going to get out of our loop. Otherwise, we are going to just sum in two different variables, the negative and the positive integers. Once we get out of the loop, we are going to have to display the sum of the positive integers, the sum of the negative one, and the average of the whole set of number with a float notation. So that's what is required of us from the textbook. We're going to get started with this code skeleton here, which is something you should be familiar with by now. Okay, it's basic out of the textbook code skeleton that we have been using for a couple of exercises so far. And I'm going to try to fix an outline for my code. Well, okay, first, we are talking about implementing a main loop. Okay, so I have the choice between a do-while loop, a while loop, and a for loop. Right now, I'm not quite sure which one I'm going to use. So let's try to think about our problem. I will need to ask the user to give me a number. I cannot really do anything until I get that number. Right? I cannot decide if I need to stop the program if, say, this number is null, or if I need to just process it and store it and for later average. So, really, in this circumstance, my choice is between a while loop, a for loop, and a do-while loop. I know that the while and the for loop are equivalent. Now, what about the distinction between while and for versus do-while loop? Well, the do-while loop is going to ask the code to be executed at least once. That's something we already covered with Raptor, and we are covering right now again with Java. So do-while means I execute the body of the loop first at least once, and then I decide if I keep going. While and for loop are going to test first if I should keep going, and then they are going to execute the body of the loop. Well, while I could write the code using either, it's obviously better to use a do-while loop. Why? Simply because I'm going to have here the code to read a number from the user. So I'm going to start my program. I'm going to execute the body of the loop, which is read a number from the user. And then I'm going to decide if I should keep going or not. What is my condition here? Well, my condition will be if the number is null, then I stop. So as long as number is different than 0, I'm going to keep looping, keep iterating. And that's brought to my attention that, yes, I need a variable here. Let's call it int number. I need a variable here to store whatever the user is entering. So I declare it before my loop, and I will use it inside of my loop. To be able to read a number from the user, I'm going to need also a scanner. So let's go scanner s equal new scanner system, uppercase here, system.in. So I declare my scanner variable. I initialize it by creating a new scanner object and putting the reference to that scanner object inside my scanner variable. And I'm going to be able to use it here. So I can do s.nextInt to read the next integer from the user. And I'm going to store this inside of number. So I'm trying to sketch out my solution starting with the most obvious. I need a loop. Well, what kind of loop? Then what do I need to do in this loop? What do I need to test? Well, when I realize that I need to test if the number given to me by the user is null, then that leads me to declare this variable. Okay? And then that leads me to realize I need to read it from the user, so I apply this recipe that we have learned so far, which is in order to read numbers from the user, you use a scanner, you declare it, you initialize it, and then you call it. So here I am. Okay, I read my number from the user. What can I do next? Well, I'm going to take care of a small detail here. Print system.out.print. I'm going to ask the user to enter a number. Okay, just so that on the screen there is a little message that invites me to type a number instead of just seeing nothing on the screen and having to guess I have to type a number. So, alright, so far I'm going to stop here, I'm going to save, and I'm going to compile my program. Okay, it's a nice place to stop because I have something that works. Okay, I have a loop that is going to keep reading a number from the user until I choose to type the number 0. So let's compile, no syntax error, and let's test this. to see if it's working. Enter a number 9. Enter a number 99. Enter a number minus 99. Enter a number 0. My program stops. Okay, so this is really important when you are designing programs to try to find a starting point. So I started by the main loop structure, okay? And when you reach something that you can compile and test, do so. Do not wait to have a full 3-page long program to start wondering if it's doing anything like what is requested of you by the exercise, okay? So we test often and we test early. Alright, so now we have this little program. What does it do? Reads an integer, keep reading integers until we type 0. What do I need to do? Well, I refer you back to the textbook, okay? Read again at this point exercise 4.2 and try to establish what is the next thing you should be tackling. What is the next task you should be tackling to develop your program? Well, I'm going to look at the exercise definition and I'm going to read into it. Well, I need to keep a sum of all integers that are positive, all integers that are negative. So I'm going to declare two variables, positive, int positive, and negative, both of type integer. Okay? These variables are going to be used to do what? Well, every time the user gives me a number, if it's positive, I store it, I add it to the positive variable. If it's negative, I add it to the negative variable. So really, those variables are sums, okay? Ongoing sums of all the positive numbers and all the negative numbers typed so far. So I'm going to call them positive sum, negative sum, just because it's clearer. And actually, let me rename them even more clearer. Positive numbers sum, negative numbers sum. And this is where you can start leveraging your experience so far with programming. What did we do every time we wrote a loop that had to make the sum of something, a sum of a bunch of numbers, etc.? Well, the sum has to be initialized to something when we start the loop, right? Otherwise, right now, positive numbers sum and negative numbers sum variables contain garbage. We don't know what they contain exactly. So we need to initialize them. What do we initialize variables that are supposed to hold a sum of something? We initialize them to 0. So positive numbers, did I spell that right? No. Positive numbers, plural, sum is going to be 0. And negative numbers, sum is going to be 0. So this is how, when you solve a new problem, you leverage actually what you learned by solving previous problem. Okay? Even though this is a new exercise, we need to integrate inside of the solution something we already used in a different context. So this is where you need to develop your code reuse and adaptation skill. It's not a matter of doing a cut and paste of some code that already do the job. It's a matter of understanding the previous exercise you did and then being able to reuse part of them in a different context. That's really what programming skills are about. So I have those variables declared. I have them initialized right before my loop. Now I can work on using them inside of the loop. So if the number given to me is lesser than 0, lesser strict than 0, this is a negative number. I'm going to do something here. What do I do? Negative numbers sum plus equal number. So plus equal simply means negative number sum equal negative numbers sum plus number. Okay, I refer you back to the textbook if you have a blank here on augmented assignment operators such as plus equal. So if the number is negative, I add it to the sum of negative number. What else can happen? If number is strictly positive, then what do I do? Positive numbers sum plus equal number. Why didn't I use else here? Well, I could have used else. No problem with that. So I could write the same code like so. Put everything here in the else statement, close it. The only reason for which I chose not to use a else statement, well, is because I can. In this case, my first if I choose to make them serially arranged because my first if statement will trigger only if the number is strictly negative. The second will trigger only if the number is strictly positive. So there is no chance for this code and this code to be executed in the same iteration given any value of number read at this line. Okay, so we are relatively safe here using either a nested statement or a serially arranged conditional statement. Now, do I want to do something in the else part? Well, not really. If it's positive, I add it to the sum. If it's negative, I add it to the over sum variable. And if it's null, well, I shouldn't be doing anything. Okay, so I didn't trigger this code. I didn't trigger that code. Okay, so what else do I need to do in my loop? Well, I'm going to stop here right now because I have already one task almost done. I should be counting how many positive and negative number we get total in prediction for the average, but that is another task. Okay, so right now, before to start adding to my code things that relate to how to compute the average of all those numbers, I'm going to just stay focused on just summing the positive and negative ones. What do I need to do after my loop if I want to just stay focused on this outcome? When I need to display sum of positive numbers equal, and I'm going to concatenate to that string the content of the variable positive numbers sum. Oops, little typo. Okay, then what? Well, once I'm done with my loop, I'm going to display the sum of positive number, and I'm going to do a cut and paste. I'm going to display the sum of negative number. So I'm reusing the same statement, okay? And I'm going to stop here once again. It's really important that you identify what you want to do to complete your code, and then stop once you fulfill that task and compile and test to make sure that you are making progress. At this point, I could go on and try to add code to do the average. That would be actually a bad programming practice because that's going to make my code more complex. That's going to kind of make me lose my focus on doing one thing at a time. So I try to compile this code. Compiles fine. I try to run it. Enter number. Well, we're going to start by interlacing positive and negative together. Okay, so enter a number, let's say 1. Enter a number, -2. Enter a number, I'm going to give 2. Another one, -1. So right now the sum of positive should be 3, the sum of negative should be -3. Okay, and then I type 0. Sum of positive numbers 3, sum of negative numbers -3. Okay, so far it looks like we are doing good with this program. What is the next step? Once again, refer back to the textbook, read again what is required of you. Okay. If I read right now, I see that we are done with a loop that keeps doing some work until I choose to type 0. I see that we are done with a part of the code that is going to sum all positive numbers and sum all negative numbers. Then what? Well, the next thing that we didn't implement it yet that I see here is display the average. So how do I display the average? Well, somewhere after the loop, I'm going to say system.out.println average of all numbers equal, and I'm going to here put a formula to compute this average. What would be the average right now? Well, that would be, I'm going to go to the next line for visibility. That would be the sum of positive numbers plus the sum of all negative numbers, parentheses around, okay, and then what? All the positive numbers plus all the negative numbers divided by the number of numbers that were entered by the user so far. Let's call it count. I need obviously a new variable here. Okay, because I didn't do anything so far to track how many numbers were entered by the user. So there we go. While I was writing my formula, which I'm going to finish right now, closing parenthesis, semicolon, while I was writing this formula, I came up with my next step. My next step is, well, okay, I need a variable count. Where do I declare it? Well, let's declare it here at the beginning. int count. What is the role of this variable? It's going to count every number entered by the user. So before my loop, 0 numbers were entered by the user. So I initialize it here right before the loop. Then during the loop, what do I have to do with it? Well, every time you give me a number, count plus plus, which is equivalent to count equal count plus 1. So I increment the number of numbers that were given to me by the user. Alright, sounds good. I save. And now let's try again our program. So to test, like I told in class, okay, you should apply regression testing, which means so far we have different test case that we use. Okay, we use a 1, -2, 2, -1, 0 series of input. This leads for sum of positive number to be 3, sum of negative number to be -3. So I jolt this down, I write this down on my piece of paper. Okay, this is my first test case. Now I added some code, so I'm going to test again the same test case to make sure it's working. Java, so my first number was 1, then -2, then 2, then 1. I actually kind of change the order here a little, -1 here, sorry. Same intent, okay? 1, -2, 2, -1 are going to be all the numbers, and then 0. Sum of positive and negative is the same than before. Average of all number is 0. Well, yes, this test case is not really good at giving us an average that we can really test our program with, because the sum of all positive and negative is going to be 0. So 0 divided by n. I cannot really tell you right now if the count is correct, because divide 0 by anything, you'll get 0. Okay, so this test case is not suitable for me to really test that part of my code. So I'll move on to the next step. The next step is trying to make a test case to check if what I added to my code, the count variable and etc., the computation of the floating point average, is actually correct. So let me run the code again, and I'm going to use a different test case. Let's say that now I'm going to enter 3 numbers. Okay, and I'm going to make it so that the sum of all 3 numbers is, say, 30. So I'm going to say first number is 10, second number is 20, so I'm already at 30. And third number, well, actually I messed that up. Third number is going to be 0. I'm going to do just with 2 numbers. So I have 30, 2 numbers only are valid. Okay, the 0 doesn't count, it's just there to serve as a sentinel value. So my average should be 15. Enter. Sum of positive numbers 30, sum of negative numbers 0. That's so far so good. Then what about average of all number? 10. Well, then you go back to your board, okay, and you figure out what the problem is. I entered a sum of 30. I got an average of 10. What does that tell me about the count variable? The count variable must be 3 right now. I could go back to my code and add a println statement to display it to make sure, but I can tell you that this is what's happening here. Okay, we have a count of 3 instead of 2. So what happened? Well, we most likely counted every single number that the user entered. Whether this number was actually 0 or not didn't seem to really matter. Okay, so now that we have a better idea of what happened, we can go back to the code and try to fix it. Okay, once again, that's what you do every time you develop code. You test it, and if you have a problem, you just don't jump back to the code to try to modify it. You figure out first what the problem is most likely to be. So, little cut and paste problem here. I'm going to fix that in once again. There we go. So, several ways to address this issue. Count is off by 1. Why? Well, this is where you have to analyze your code. Okay, I increment count here. If I enter 0 here, this code is not triggered because the if is not true. This code is not triggered because the if is not true. And I trigger count plus plus. So when I finally type 0, before I have a chance to check here if I should get out of the loop, well, I have already incremented count. So I can fix this different way. First, and this is the approach I'm going to take, if number is different than 0, then count plus plus, which means I'm going to increment count only if number is different than 0. Another possibility I could have explored, if number equals 0, break. So I'll refer you back to the end of your chapter, okay, to check what the break statement is doing, but that could be an alternative to this one. Okay, I could just say, well, if number is 0, before to do anything else, such as incrementing count, I'm breaking out of the loop. Okay, so that's possibility number 2. Possibility number 3 would be, instead of doing this, okay, so it's all exclusive, okay, instead of doing what I'm highlighting right now, I could simply, after my loop, decrement count by 1, because I know I'm going to be always off by 1. Or I could simply, in the equation itself, divide by count minus 1 instead of count. All of those approaches, and I'm sure we could find a couple more, all of those approaches are strictly equivalent, so I'm just going to go with this one. I'm going to save, and I'm going to make sure that it works. So, go back to my console here, compile. No problem. Run it. Let me go through my 2 test harnesses so far. 1, minus 2, 2, minus 1, 0. 3 minus 3, average is 0. That's fine. So I didn't break anything. Then, second test harness. 10, 20, 0. The sum of positive is 30, the sum of negative is 0, average is 15. Okay, we have like good indication now that our program is working. The only test that I would add is probably something such as 20, 30, so our sum is currently 50, minus 20 to put it back to 30, and then 0. Why did I add this? Well, to make sure that when I have a mix of integers that are positive and negative, my average is still valid. So let's see what we have here. 20 and 30, that's 50, minus 20, that's 30. We have 3 valid number, therefore the average is 10. And that's correct. So I have now all of my test cases, and this is the version of my code that is actually solving what is requested of me in the textbook exercise.